Hello everyone. Today we're going to go over the fundamental theorem of calculus and what it means to say that the integral is the area under the curve. So I have written out here formally the fundamental theorem of calculus, and it states that if we have some function capital F of x and we take its derivative, and that derivative is equal to f prime of x, then the integral on some interval a to b of f prime of x, or the derivative, is equal to big F of x, or the function that we started with, evaluated on that interval. Okay, so what this is basically saying is, if you have a function and you take its derivative, and then you take the integral of that derivative, you get the function that you started with. So derivatives and integrals are inverse operations, just like multiplication and division. You know, if you multiply a number by another number and then divide by that same number, you get the number you started with. And so the same thing is true for functions when you're taking derivatives and integrals. Okay. So the best way to visualize what's going on here, I think, is using a linear function. Very simple function, and we know a lot about them. For one, they have slopes, or derivatives. And slopes are the rise over the run of the line, or how much it changes vertically over how much it changes horizontally. And for linear functions, their slope is not changing. They have a constant slope. And so we're going to let that be m. So I have graphed out over here the derivative graph of this function right here. And you can see it's just a constant function and just a horizontal line all the way to infinity, and it constantly stays at the value of m. And so you might ask, well, what if we just have the derivative graph and we don't have the actual function, and we want to find the actual function? Well, the way you actually go about doing that, which is actually really intuitive once you see it, is by looking at the area under the graph, or the curve, that is the derivative. And so, to do that, well, this is just basically one giant rectangle, one infinitely large rectangle. The area of a rectangle is the length times the height, or the height times delta x. And so since it's at a constant height of m, we have the area on some interval, a to b, is going to be equal to the height times delta x, or the change in x, or the length. Okay, and so I'll show you now how this is actually the same thing as f of x. So look, if we substitute in for m what we know it to be, which is delta capital F over delta x, then we get that the area is equal to delta F over delta x times delta x. And the delta x's will cancel, and you just get, I'll bring this up here, you just get delta F. Okay, so the area is actually, under this straight horizontal line, is just delta F. And if you evaluate this on the interval that it's supposed to be evaluated in, like the interval of which f is actually changing, then you get the same thing that's written up here, which is the final value, or the value of f at the final point, minus the value of f at the initial point. And so that's how you get from the derivative to the function whose derivative that you're looking at. It's a fundamental theorem of calculus.